In today's lecture, we're going to talk about SQL data types. There are three data types that we're going to talk about today. Numeric data types, like integers and floats, the date-time data types, and then the string data types. Numeric data types can be broken down into two different classes. The first class is our integers. By default, SQL, MySQL, MariaDB use signed integers. What I've shown here are the ranges for unsigned integers. So that the maximum by default is, for example, a half of what I've shown here. A tiny int is ranging from -128 to 127. You may recognize these data types as being similar to other data types in languages that you're used to, like Java or C++. The tiny int is an 8-bit integer and is, of course, equivalent to the Java byte. A small int is a 16-bit number and is equivalent to the Java short. The medium int is a 24-bit number. And what's that equivalent to in Java? That's right, there isn't really an equivalent number. It's a trick question. The int, or integer, in SQL means the same thing. Of course, in Java, an int is a primitive and an integer is an object, and they're different things. The int is the standard 32-bit integer, and the big int is a 64-bit integer for larger numbers. In addition to these ranges of integers, SQL can also handle more complex types, like the bit, the Boolean, the float, the double, or currency-associated data types. The bit takes binary data in the range of 0 to 64 bits. A Boolean stores yes, no, or true, false values using a tiny int 1. Yes or true is stored as 1, and no or false is stored as 0. Floats and doubles are not very accurate, but quick approximations. Floats can be single or double precision floating point numbers using either 4 or 8 bytes respectively. Note that you should never use floats or doubles for currency calculations in any programming language, but especially in SQL. One solution that people often use is to use integers for currency calculations and then divide by 100, doing all the calculations on the pennies, for example. Because we often build databases that involve currency, MySQL, MariaDB have a decimal data type that allows you to store specifically things like currency. You can store other numbers in the decimal data type too. The decimal data type takes two arguments, a precision and a scale. The precision is the maximum number of digits that will be stored in the number, including those on either side of a decimal point. The scale is the maximum number of digits after the decimal point. The precision can be up to 65, while the scale can be any number less than the precision. You can't have more numbers on the right of the decimal point than you have numbers in total. For example, if we have decimal 9,2, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 nines in these numbers. The range of the numbers is from -9,999,999.99 to +9,999,999.99. Note that MySQL will silently truncate things that are too big to go in a decimal field. It'll truncate it to the maximum value. And so, if you're trying to store my bank account, don't use decimal 92 because it would truncate that number that you try to add to $9 million. Well, maybe one day. The numeric data types can take a couple of options. For example, you can say I want the numbers to be 0 filled. If you use int8 0 fill and you insert 1, 2, 3 into that field, it will display as 0, 0, 0, 0, 0, 1, 2, 3. That would be 5 zeros and then your 3-digit number. It's filling out the 8 digits there with zeros. You can say I only want you to display 6 digits, filling out those with zeros by using the width option. The width is only for zero fill. It tells you how many zeros you're going to have in front of the number. And then, as I mentioned previously, you can have signed or unsigned integers. Signed values are the default. By providing the unsigned keywords, you can get unsigned values. So there's a special class of numerics that we often store in databases called dates and times. And MySQL and MariaDB have special numerical types for handling date and time formatted numbers. The date is usually kept in year, month, day notation, which allows rapid sorting of numbers, of dates rather, in generally chronological order. Time is stored as hours, minutes, and seconds, and so we can put those together into date time, which gives us years, months, days, hours, minutes, and seconds. We can also store just the year as either 2-digit or 4-digit numbers. And of course, if we're using 2-digit numbers, we need to worry about things like Y2K problems, right? So notice here there are two fields, date time and timestamp, that have the same format. Timestamp is different from date time because it stores the values as seconds since the epoch. The epoch is time 0 on your computer. It's a little bit different for each operating system, but it's sometime around January the 1st, 1970. At that point, computers started counting, incrementing once per second. And generally, times on computers are stored as seconds since the beginning of time. So timestamp actually stores seconds since the epoch and not the specific time that you put into the database. If you insert a null value, then the current time gets put into the timestamp field. So there's a trick that you can pull with MySQL where you create two timestamp columns. And you never say that you're going to insert anything into any of them, ever. What happens is the first time you do an insertion, because you're not inserting anything into that column, MySQL will put a null in there. So the current time gets put into both columns. The second time you update the table, you do an insert, but you don't specify a timestamp column. Only the first one will get updated. All of the subsequent ones won't get updated. So this provides a mechanism to create an automatic create and update timestamp. If you have the first column called update, that's a timestamp data type, and a second column called create, that's a timestamp data type, whenever you insert something, the create field will be updated with the current time, and then as you update, the time gets updated. So we've talked about numeric data types. Let's take a look at the string data types. You may recognize these string types, char, tiny text, text, medium text, and long text, as having counterparts in the numeric data types that we've already looked at. And indeed, they're based on the same concept. Tiny text, text takes 2 to the 8 bytes. Text takes 2 to the 16 bytes. Medium text takes 2 to the 24 bytes, and long text takes 2 to the 32 bytes. Notice that even though we're storing characters, we're measuring this in bytes. The number of characters that you can put in one of these fields depends upon the character encoding that we're going to use. The long text field takes up to 4 gigabytes. If you're going to store 4 gigabytes in a database, you may end up with some input-output issues accessing data from your database. An alternative that we can explore is to create a field to hold a file name and then to index seek positions in that file. In a subsequent class, we'll look at indexing text files and rapidly sequencing to a point in a file. The number of characters that you can store in the database depends upon the character encoding that you're using. UTF-8, one of the standard character encodings that we use 1 byte for basic letters and digits. It uses 2 bytes for letters with accents, and it uses 3 bytes for Korean, Chinese, and Japanese characters. So depending on the character set that you're actually using depends on how many characters you can store in the database. The last type here, varchar, is a variable width number of characters, and that allocates memory based on what's being inserted into the database. The first string type, char, here is fixed width, right padded, and up to 250 characters, 55 characters wide. What that means is the strings are right padded. The field to the right with spaces. If you insert a small string into your char field, then there are spaces that are inserted that you won't be able to see that fill it out to the total number of characters of that field. It's important to remember that some string types are defined in terms of characters, and some string types are defined in terms of bytes, as shown in this table. So which data type should we use? If you have a small amount of text and you want to put it into a MySQL database, then there's 3 different options you could use. You could use a char, you could use a varchar, or you could use a tiny text. It depends on the type of data that you're putting into your database. Char 30 allows 30 characters long strings, padded with spaces, of fixed length. The advantage of using something like this is if you're using stocks or inventory systems where you have a part number or a part identifier that you know is going to be up to 30 characters long and no longer. Varchar 30 allows you to store 30 characters, but any more characters than that will be truncated down to 30. Varchar 30 would be great if you're creating something like a mailing database where you know that the entries in the database are going to be printed onto envelopes, and they need to be a certain length, otherwise they're not going to fit onto the actual physical envelope. Or you don't want to have a string that goes all the way across the page in your letterhead. Tiny text allows you to insert up to 255 characters, but you don't know how many characters they're going to be. So this would be great for something like a name field, where you don't know how long the name is. Hopefully the name is short, but some people have somewhat longer names. It's unlikely that anybody has a name longer than 255 characters, though. It'd be very hard to pronounce that. So we've looked at the numeric types, we've looked at the date-time types, we've looked at the string types. There's one other type to look at, and that's the binary equivalence of the string types. So the string types, char, varchar, tiny text, text, and long text, hold strings, but we can also insert binary data into our database. For example, if we're creating a database of images, we might want to insert the whole image into our database. We can do that by creating a binary field, inserting the image into the binary field, and inserting and retrieving binary data. Of course, if we're creating a database of images, an alternative way of doing it is to create a directory and then insert a text field where we provide a path and a file name for a specific image. There are pros and cons to each. The text field would allow us to serve the image directly in a web page, for example. Including the image in the database minimizes the chance that the files will be moved or deleted and the database won't be updated. It would avoid an update anomaly. How you do that may actually depend upon other requirements for your particular system. Finally, there are two special types of data that we need to look at in MySQL. The first is the enum, which is a column of lists. So you maybe have yes, no, male, female, maybe, wrong, or right. You can define the list. You can store information as a list. What actually gets stored in the database is the index position in the list. So for my last example here, what would be stored would be for maybe, would be 0. For wrong, it would be 1. And for right, it would be 2. We can then actually do some arithmetic on that. So we could extract the value associated with 2 wrongs, 1, add them together, and get a right. If nulls are allowed in our database, then that would be the default. Otherwise, it's the first entry in the list. And so you might want to set up your list either a yes-no list or a no-yes list, depending on what you want the default answer to be. Similar to enums, there's a set data type which can contain one or more values. So for example, we could have a set of classes that a student might have taken: CS107, CS108, CS310, and CS503. In the database, those classes are actually stored as bits, 1 bit for each particular class. And we just simply add up the values that are true, so we could say 0001 for CS107 and 0100 for CS310 would give us a decimal value of 50101 to indicate that those two classes had been taken. And a bitwise value of 0111 would imply that you've taken 3 classes. If you use a set in your database, which of the normal forms will your database correspond to? That's a rhetorical question for you to figure out the answer to. So we've talked about numeric, date-time, string, binary, and then special data types, really as it relates to their use in MySQL or MariaDB. But other relational database systems have similar data types, and I compiled a table that's available at the URL shown at the bottom of the screen. This table shows you a comparison between the data types in the different database systems. As you can see, there are many similarities between each of the database systems because some of the data types are SQL standards. But each database system has its own ways of handling particular data types. So depending on the specific implementation of your SQL database, you may need to slightly adjust the data types that I've talked about today to fit with your system. That concludes today's class.